Hi everyone, welcome to my video on growing sodium chloride salt crystals. My name is Arik and today I will guide you through the exciting process of making beautiful crystals at home while explaining the solid state theory behind their formation. Before we go into the procedure, let's talk about the introduction for further understanding. Did you know that salt crystals have unique structure called a cubic crystal system? Specifically, they form a face-centered cubic crystalline structure, or FCC for short. Let's break this down. Each sodium chloride unit cell is made up of equal parts sodium ions, represented by the red spheres, and chloride ions shown as the blue spheres. This arrangement ensures perfect balance between positive and negative charges. Now, let's talk about the unit cell itself. Sodium ions occupy one position in the center and parts of the edges, while chloride ions fill the faces and corners. Each ion has 6 nearest neighbors of the opposite charge, making the structure incredibly stable. Finally, what is remarkable is how every sodium ion is surrounded by 12 second nearest neighbors of the same charge. This arrangement is what gives sodium chloride its characteristic cubic shape and strength. Pretty amazing, right? This structure is why we see those perfect cubic salt crystals when we grow them. To get started, you will need a few simple materials, each chosen for a specific purpose to ensure the best results in our experiment. First, we need table salts, which provides the sodium and chloride ions that will form our crystals. Then, we will use hot distilled water instead of tap water. Using hot water helps the salt dissolve more quickly and completely, ensuring a saturated solution. We also choose distilled water because it's pure and free from impurities that might interfere with the crystallization process. Next, a clear glass or jar is important. Its transparency allows us to easily observe whether the salt is fully dissolving. We will also need a shallow dish for the evaporation process. The white surface area of the dish helps the water evaporate evenly and slowly, which leads to larger and more defined crystals. And finally, a spoon is essential for stirring the solution, helping the salt dissolve evenly in the hot water. With these materials ready, we are all set to begin. Now, let's jump into the demonstration. Here are the materials you'll need: table salt, hot or warm water, spoon, beaker, and a petri dish. So let's get started. First, pour some hot water into a beaker, about halfway full. Next, take your salt and start adding it to the water. Stir well after each addition and keep going until the salt no longer dissolves. At this point, you will notice that the salt stops dissolving and begins to settle at the bottom of the beaker. Next, carefully pour your saturated solution into the second beaker. Be sure to leave any undissolved salt behind. This step helps ensure your crystal will grow clean and clear. Over the next 3 to 7 days, water will evaporate, leaving behind cubic crystals. The smaller crystals is removed to allow the larger ones to grow. After several days, you'll have these stunning cubic crystals. Look at the sharp edges and defined structure, a clear demonstration of sodium chloride's molecular arrangement. Let's start by understanding how sodium chloride crystals form. The process begins with dissolution. When sodium chloride is added to water, the ionic bonds between sodium and chloride ions are broken. Polar water molecules surround these ions, pulling them apart and dispersing them into the solution. The reaction can be represented as sodium chloride solid dissociating into sodium ion and chloride ion in aqueous form. Next is saturation. At this point, the solution reaches a balance where no more salt can dissolve. This happens because the water molecules are already busy interacting with the maximum number of ions they can handle at a given temperature. As water evaporates, the solution transitions to supersaturation. Now, there are more ions in the solution that it can normally hold. This unstable state is critical because it's starting point for crystal formation. Now, let's look at how these dissolved ions transform into solid crystals. The first step is nucleation. In a supersaturated solution, sodium and chloride ions begin to come together, forming tiny stable clusters called nuclei. These are the building blocks that initiate the crystallization process. Next, we have crystal growth. Once the nuclei are formed, they begin to attract additional sodium and chloride ions. This causes the structure to grow into a repeating crystal lattice. In the case of sodium chloride, this lattice typically takes the form of a face-center cubic structure, which is both stable and symmetrical. Finally, the process concludes with solidification. As water continues to evaporate, the crystals grow larger and become fully solid. The once dispersed ions now form well-defined, visible crystals, completing the process of sodium chloride crystals formation. Now, let's take a look at the results of the sodium chloride crystal formation process. First, we observe crystal presence. A small square-shaped crystal is clearly visible within the petri dish. This is the sodium chloride crystal that formed during the experiment, showcasing the successful completion of the crystallization process. Next, we note the solution clarity. The liquid in the petri dish appears clear, indicating that most of the sodium chloride has crystallized out, leaving behind minimal dissolved ions in the solution. And with that, we conclude our discussion on the fascinating journey of sodium chloride crystal formation.